Okay, so this one turns out to be not really as much of a problem with the inverse trig functions as it is a simplification with the product rule. So the arcsine x part is easy because that's exactly our rule, so we don't have to make any changes to it. So it's just going to be 1 over the square root of 1 minus x squared. So f prime of x, 1 over the square root of 1 minus x squared. Okay, and then most of you guys are doing the product rule right. It's just the simplification that's killing you. So we're doing first and then times the derivative of the second. We're treating this as 1 minus x squared to the 1/2. Most of y'all are pretty good at that. So 1/2, 1 minus x squared to the negative 1/2 times the derivative of the inside. So that's first, that's derivative of the second, plus the second. So 1 minus x squared to the 1/2 times the derivative of the first, which is just 1, which is fortunate because I'm out of room. Okay, so then I'm going to rewrite this as 1 over the square root of 1 minus x squared. Your half and your negative 2 cancel. Okay, so that makes, well, the 2, not the negative. Okay, the half and the 2 will cancel. So, and I'm going to move this part with the negative to the denominator. So that'd be positive 1 minus x squared to the 1/2 if you move it. What's left to be in the numerator? Okay, and I'll just put a plus here. And then you've got this guy. Okay, so what I did was, this part's easy. We've got a common denominator, so that's the 1 minus x squared. This guy, to get a common denominator, what would I need to multiply by? Okay, so the square root of 1 minus x squared over the square root of 1 minus x squared. Okay, that way I'll have the same denominator. So I'm going to go ahead and combine these two guys. So I just have 1 minus x squared. And then over here, I've got the square root of 1 minus x squared. And then what's the square root of 1 minus x squared times the square root of 1 minus x squared? Okay, so I can go ahead and combine these now. And so I'd have what in the numerator? And if you got here, like I know Gaddy did, then you did a really good job. Yay. You might have something similar. Okay, that's fine. Okay, and then one more thing you can do is you can factor a 2 out of the numerator, and that leaves you 1 minus x squared. And that's helpful because square root of x squared is actually 1 minus x squared to the 1/2. So when you divide, what do you do with your exponents? Right, so this would be 1 minus a half, so it would be 1 minus x squared to the 1/2. So you could just leave it like that. Okay. Now, as far as how far you need to go to simplify things, just think about it in terms of what would I be doing next if you're going to be taking a derivative and finding critical points and stuff like that. As long as you've got it to a point where you can set the numerator and the denominator equal to 0 and solve it easily, then you've gone far enough. Okay. All right.
Okay. This is Carla. Okay. So the first thing you're gonna do is I can put, I guess, the rules over here, like slide them in. You're gonna take the derivative of the arc cosine, and that'll be prime of x is equal to 1, negative 1 over square root of 1 minus, and then you're gonna plug this in for where it says x, 2x squared times the derivative of this, of the inside function, and that'll be 2e to the 2x. And then to simplify that, you'll get negative 2e to the 2x divided by the square root 1 minus e to the 4x. Ta-da! Oh, Oh, for the 4x is when this e to the 2x is squared, you multiply that and you get 4x.
Okay, so since this has a mixture of x's and y's, we're not isolating the x or the y. It's going to be implicit differentiation. How do you take the derivative of ln of something? Okay, so I agree with the 1 over x plus y. Okay, because the derivative of ln of x is 1 over x, so the derivative of ln of x plus y would be 1 over x plus y. But then we need to say times the derivative of what? Right. Okay, so what is the derivative of this? Perfect. Okay, and then we need to take the derivative of arctan of x over y. So we're going to be substituting x over y into the arctan function, and then times the derivative of x over y, which is going to be the tricky part. Okay, so if you look at your arctan rule, it's 1 over 1 plus x squared. Okay, so for us, it's 1 over 1 plus x over y squared. And then I've got to say that times the derivative of x over y. Okay, so what rule am I going to have to use for times the derivative of x over y? Quotient. All right, so here we go. Low is what? D high minus high. D low. Nice. Over low squared. All right, so we got a giant mess. Our idea once we do implicit is to get everything with dy dx on one side and everything without it on the other. Okay, but I kind of have a mess to deal with first. Part of the mess is that I have a whole lot of fractions. So let's try to deal with that first. Okay, so let's look at this guy. This would be 1 over 1 plus x squared over y squared. Okay, and all this is multiplied, so that's times y squared. And this is times y minus x dy dx. Any reason why we didn't combine which part? This? Nope, you can if you want. Basically, I'm going to try to get rid of all the fractions before I do much. So if you look at this guy, I might as well go ahead and distribute this. Okay, so if I do, what would I have in the denominator? X squared y squared over y squared, right? Okay. Okay, and again, it's fine if you wrote this part in the numerator. So what I'm going to do is multiply everything through by something so I can just ditch all these fractions. So if I want to get rid of all my fractions, what could I multiply through by? X plus y would get rid of that part. What else? Yes. I know, right? So we're going to have x squared plus y squared and x plus y. So we're just taking both denominators, multiplying both sides by the combination of both denominators. Okay, so that's both sides of our equation. Okay, so over here, what's going to happen on the left-hand side? Correct. So the x plus y's cancel. So I've just got x squared plus y squared times 1 plus dy dx. Over here, what do I have? Yes. Okay, and that's because these guys canceled. Okay, so now suggestions on what to do. FOIL. Yeah, we're just going to FOIL everything out, get everything with dy dx on one side, everything it doesn't on the other, and we're done. Okay, so once you get rid of the fractions, this is a lot less of a mess. Okay, so help me out with foiling. You're doing it in such a crazy order that I'm going crazy, but I'm trying to write it down your way. X squared dy dx plus y squared dy dx. Okay, I agree. No, he was correct. Okay. All right, and foiling this one, boy, I hope you do this one in order. I'm going to have trouble keeping up with you. Uh-huh. It's all right. Keep going. Mm-hmm. Okay. It's all right. You just distributed different order. Perfectly fine. Okay, so all I'm going to do now is gather everything with dy dx. Is the left-hand side all right with y'all? Okay, so x squared dy dx stays where it is. Y squared dy dx stays where it is. I'm going to bring over this guy and this guy. Okay, so when I bring it over, it'll be plus x squared dy dx plus xy dy dx. And then on the right-hand side, I still have the xy and the y squared. And I need to move these guys over. So minus x squared minus y squared. Any simplification? Okay. And over here, I guess we can make that 2x squared, right? So let's factor out the dy dx. What would that leave us all together? Mm-hmm. And final step. Okay, so you can write it again if you want, but that is your glorious answer. Yes. Didn't mean to traumatize you. Okay, and then your homework is at the bottom. And there it is. Number 41 is a typo, so if you would correct it to read what this says.